In this section, we're going to graph some combinations of trigonometric functions and also trigonometric functions with regular algebraic functions. We're going to start with a problem that's similar to some that we've done before. We're going to look at it from a little different point of view, though. Here's our first problem. For problem number 1, we have y is equal to 2 minus cosine x. Now, I'm going to look at this, and we want to graph this between x equals 0 and x equals 4 pi. I'm going to look at this as two separate functions right here. The first function will be y1, which is equal to 2, and then my second function is going to be y2, which I'm going to say is negative cosine x. First of all, let's graph y1 is equal to 2. That's just going to be a straight line through 2 on the y-axis. So that should be a perfectly horizontal line, and this is y sub 1 is equal to 2. Now the second graph is y sub 2 is negative cosine x. It's cosine graph reflected about the x-axis. So it'll start at negative 1, go up to 0, then up to positive 1, back down to 0, and down to negative 1 between 0 and 2 pi. Then it does the same thing again, because the period is 2 pi, so it will look like this. So here's my graph of y sub 2, and y sub 2 is equal to negative cosine x. Now what I want to do is look at the graph I'm trying to graph right here as the sum of these two graphs. So for any particular value of x, the value of y that I get for this function right here will be the sum of this value of y plus this value of y. So what that means is that I can think of this as taking the green graph right here and adding y equal 2 to each value of y on the green graph. So let's try that. Here's negative 1. When I add 2, I end up with 1. Here's 0. When I add 2, I end up with 2. At pi, y is equal to 1 plus 2. That will be 3. Here, y is equal to 0, plus 2 is 2. Negative 1 plus 2, positive 1, 0, I get 2. Then it goes back up to 3, back down to 2, and then down to 1. So the blue graph is the sum of this yellow curve right here, y1 equal to 2, and this green curve right here, y2 equal to negative cosine x. So I can think of every y value that's on this curve as coming from the sum of, for instance, for this value of x. This value of y plus this value of y is going to give me that value of y. So it's like adding two graphs together to get a third graph. Let's try another one of these. This time I have a combination of an algebraic function and a trigonometric function. So I'm going to do the same type of thing, and I'm going to say let's let y1 be equal to x, and I'll let y2 be equal to sine pi x. Now let's graph y1 first. y1 is equal to x, so that will be easy to do. It's just a straight line. Starts at the origin, and I'll just make it go up to 8, 8. So here is the graph of that first function, y1 is equal to x. Now I'm going to graph my second function here. y2 is equal to sine pi x. This has a period of 2 pi divided by pi, which is 2. So the period for this graph is 2 pi divided by pi, which comes out to be 2. So it's going to be just a regular sine curve with an amplitude of 1. It'll go through one complete cycle between 0 and 2, 2 and 4, 4 and 6, so on and so forth. So it'll start here at 0. It will go up to 1, back down to 0, down to negative 1, and back up to 1. So let me see if I can draw that in. Now it's going to continue in that same manner between 2 and 4, 4 and 6, 6 and 8. I'll try to do this nice and neatly. I hope it's not too small here that you'll be able to see it. And one more time, and there we have it. How does that look? Okay, that looks good. So here, my graph that goes along here is the graph of y2 equals sine pi x. This graph, this straight line, is the graph of y1 is equal to x. And what I want to do is add y coordinates on these two graphs, and I'll have the graph of this combination of functions up here that I'm looking for. So let's start by looking at everywhere that the red graph here is 0. When I add those y coordinates to the green graph, I'm going to be on the green graph. So here the red graph is 0, so I'm on the green graph. Here red is 0, so I'm on the green graph. And I think you can see it's going to be 0 at all these points, so I'm going to get these values for the sum of the two y coordinates. Now everywhere that the green graph is up 1, I'm going to add 1 everywhere that the red graph is 1, I'm going to add 1 to the green graph. So here I'm going to have to add 1 to the green graph at this point. I'm going to get this point. Here I'm going to add 1 to this. I'll get that point. Here I'm going to add 1 to the green graph. I'll get this point. Here the red graph pushes the green graph up by 1, so I'll get this point. Everywhere the red graph is at -1, I'm going to pull the green graph down by 1. So here the red graph is -1, I'm going to pull the green graph down. Over here I have -1, so I'll pull this down about 1. I'm just going to have to estimate here. Over here, and it'll come down 1. And over here, whoops, where did I go? Over here, it's going to come down 1. So from there down 1. Now, let me see if I can connect these with a smooth curve. I get something that looks like this. A graph that looks something like that. It looks like a distorted sine curve that sort of winds around the line y is equal to x. And I'm doing this by just drawing my two separate graphs as accurately as I can and then sort of adding y coordinates visually to see what I get. What I want to do next is take the graphing calculator and see if the graphing calculator will confirm that this graph that I've drawn right here is approximately what this graph should look like. Let's go to the graphing calculator. Okay, here I've got my calculator. Let's look at my y variables list. I'm going to graph y1 as x, y2 is sine pi x, and y3 is equal to x plus sine pi x. Now, if I go to my mode button, let me just press the mode for a second so you can see. I've changed my calculator to radian mode. Before, I think last time I showed a calculator problem, we were in degree mode. Okay, now let's go to the window. I'm going to graph from x equals 0 to x equal 8 in increments of 2. For y, I'm going to go from y equal -2 up to 8 in increments of 2. Let's see what we get. There's y is equal to x. There's that sine curve. Goes through 4 cycles. Now there's my curve that's winding around, and sure enough, it resembles that graph that I drew by hand. I'm sure you realize that I graphed this first on the graphing calculator before I actually made this sketch right here, so I wouldn't mess it up too much. But you can see that my hand sketch here and what I got on the graphing calculator do correspond with each other. So this method of sort of eyeballing the y coordinates and moving the one graph up and down an amount equal to the y values on the other graph is a good method of graphing these fairly complicated equations. I want to try one more in this section. Problem number 3, we have y is equal to 2 sine x plus cosine of 2x. So I'm going to set this up so that y1 is equal to this function and y2 is equal to this function. I'll graph this. It'll be a sine curve with an amplitude of 2. So between 0 and 4 pi, it should go through 2 complete cycles. This will be a cosine curve with an amplitude of 1 and a period of 2 pi divided by 2, which is pi. So this shouldn't go up as high as this, about half as high, and it will go through 1 complete cycle in pi units. So it's going to end up going through 1, 2, 3, 4 complete cycles between 0 and 4 pi. Then what I'm going to do is try to get the graph of the whole thing by adding the y coordinates of these two. Before I do that, though, let's go to the graphing calculator and get an idea of what this graph looks like ahead of time. Let me show you how I got the y variables, how I have the y variables set up. First of all, y1 is 2 sine x, y2 is cosine 2x, and now I put y3 is y1 plus y2, because that's what I'm doing, isn't it? Adding those y coordinates. Look at my window. I'm going to have x go from 0 to, this is 4 pi in increments of pi over 2. Y is going to go from -3 to 3 in increments of 1. So I'm in my radian mode, so I put in for x maximum 4 times pi, and it gave me that decimal. Let's take a look at the graphs. First will be y equal 2 sine x. See, it has an amplitude of 2 and a period of 2 pi. Here is my cosine curve. It has an amplitude of only 1, and it has a period of just pi. And there is the sum of those two graphs. See, it winds its way around, takes a big dip down there, and then comes back up. Okay, so let's see if I can reproduce that same kind of graph here by hand. First of all, y1, I'm going to let that be equal to 2 sine x. So let's write that over here. y1 is equal to 2 sine x. Now let's sketch the graph of this real quickly. An amplitude of 2 and a period of 2 pi. Well, it's a sine curve, starts at 0, goes up to 2, back down to 0, down to -2, and then back up to 0. That's one complete cycle. Now it's going to do it again over here. Goes from 0 up to 1, back down to 0, up to 2, down to negative 2, and then back up to 0. Let me connect these with a sine curve. These pens are a little hard to draw with, but yeah, that's not too bad. Next, we're going to let y2 be equal to cosine 2x. So I have cosine of 2x. Now that's going to have an amplitude of 1 and a period of 2 pi divided by 2 here. So that's going to give me a period of pi. Cosine curve starts at 1, and then it's going to end pi units later at 1 again because the period is pi. In between it'll be negative 1, and I'll go there and there. So let's see. There's that one complete cycle of that cosine curve. Okay, now I want to do the same thing again. Here, here, and here. Again, it's going to start there, end right here at 1. It's going to be down to negative 1 right here, here and here. Okay. Okay, here it starts at 1, ends at 1, goes down to negative 1 in between, and hits 0 in between there and there. Okay. Well, let's see, that dips down a little low. Let's just do this a little bit more accurately. Okay, so that's what the graph of y2 equal cosine 2x looks like. Now what I'm going to do next is try to add the green graph that I have and the yellow graph together. That will give me the graph of the whole function right here, and hopefully it's going to look like what we had when we graphed it on the graphing calculator. Here we go. First of all, everywhere the yellow graph crosses the x-axis, I have a y coordinate of 0, which means I'm going to be on the green graph. So let's first of all go down and see where the yellow graph crosses the x-axis. Here, y is 0 on the yellow graph, so I'm on the green graph. Over here, y is 0 on the yellow graph, so I'm on the green graph. Here, y is 0 on the yellow graph, I'm on the green graph. Same thing here, and same thing over here. So I get those points. Let's do the same thing now with the green graph. Every time the green graph crosses the x-axis, I'm on the yellow graph. So here the green graph is 0, so I'm on the yellow graph. Same thing here. Then over here, let's see, there I'm 0, so that's 0. Here it's 0, so there I'm on the yellow graph. Here the green graph is 0, so I'm on the yellow graph, 0 on the yellow graph. Over here, green graph is 0, so I'm on the yellow graph. Here the green graph is 0, so I'm on the yellow graph. Now I need a few more points. Let's look at these points right here where the green graph is negative 1 and the yellow graph is negative 2. Their sum is going to be negative 3. Same thing over here. The green graph is negative 1, the yellow graph is negative 2. When I add them together, I get negative 3. How about these points right here? The yellow graph is 2, the green graph is negative 1, so their sum is positive 1. Same thing over here. So let's see. If I connect them with a nice smooth curve, does that look like what we got when we graphed this on the graphing calculator? And the answer is, it's pretty close to what we got when we graphed this using the graphing calculator. The red graph right here is the sum of the green graph and the yellow graph. So I graph, first of all, this function in yellow as accurately as I can. This function right here I graphed in green as accurately as I can. And then I go through and add the y coordinates at some specific points on the x-axis. And I look, first of all, for the points where one of the graphs will cross the x-axis, because the sum of the two curves at that point will be the other graph. So I do that with the yellow graph, and then I did it with the green graph, and then I looked for some other specific points. I got this kind of curve right here. You should practice these problems whether you have a graphing calculator or not. Try to get them done by hand and see if you can take one that's fairly complicated but symmetrical like this and see if you can reproduce it by hand.